Hello, everybody, and welcome to this session of the Autocall training webinar series. My name is Pete Ryan. I'm part of the marketing team for the Global Fire Detection Products business at Johnson Controls, and I'm sort of your host slash cruise director for today. I'm very proud and happy to welcome on this session to do the presenting Roger Reiswig. Roger is our fellow and vice president of industry relations at Detection Products, and he has spent many years with the company and many years in industry relations as part of various committees and teams and task groups doing research at NFPA and the Automatic Fire Alarm Association and FFPE and all sorts of other places. So Roger knows pretty much everything there is to know about code and what goes on in the fire alarm industry. So we're very pleased to have him as part of JCI and pleased to have him as part of our group. Today, Roger is going to spend some time going through NFPA 72 2019 edition. He'll highlight some of the changes and what they mean for how we do business and how our projects come together. And he'll also give us a little bit of insight into what he sees coming for 2022 in the next edition. You can do the next slide, Roger. In the era of COVID here, I know that we're all getting webcasted in Teams and Zoomed, so we're all quite professional at all these now, but again, we're on the WebEx platform here. You're all in mute and listen-only mode, and what we'll do is we'll open up for questions at the end. There is a Q&A box up at the upper right-hand corner there. Click that, put in your questions, or use the chat box. Aaron and I will be monitoring them, and we'll collect them all together and make sure that we get to them at the end of the session. At the end of the session, also, we'll be happy to take audio questions if you'd like to ask them verbally. And we'll just use the little raised hand icon there to let us know that that you have a question. We'll unmute you, and away we'll go. The final thing here is, as usual, we're recording this session. Everything that is said on the session and all the comments that are typed in the interface are recorded as part of that session. And what we'll be doing is posting this later on the autocall.com website, the authorized distributor section, so that anyone who may have missed it can download it and replay it. So just want to make you sure that you're all aware from a privacy standpoint, and also that if you're uncomfortable with that, feel free to drop now, and you can listen to the replay after. So with all that sort of housekeeping out of the way, I'll pass it on over to Roger, and he can get started delving into the content. Roger?
Well, thanks, Peter, and appreciate all you do to set things like this up and to support us the way you do, you and the team. Appreciate that. Thank you all for taking a little bit of time today to be with me and Peter as we go through a little bit of what's changed in 72. Although NFPA 72, the 2019 edition, has been out for a few years now, and the 2022 edition is being worked on. We have to remember that states states don't adopt codes and standards immediately, with a few exceptions, but pretty much take a little bit of time. And with that being said, we're starting now to see a few states, even more states, adopting the 2019 edition. So we're starting to get more and more questions about the 2019 edition and some of the changes that have occurred. So we thought it would be a good idea to go through this seminar with you today to arm you with some of the content. Some of the changes that have occurred that I've pulled out. So I kind of went through the document, looked at what I thought would be the most beneficial for you to know in our hour or so that we're going to spend together here today. And the presentation, I kind of set it up as a way for you to kind of see what's changed, what's been taken out of the code with the red strike through as we go through the slides. Blue underline is going to mean the text is modified or it's new altogether. And then black text is exactly what it was in the 2016 edition of the code. So we'll just jump right into it, into 72. One of the biggest changes that occurred had to do with pulling in carbon monoxide detection into 72. And I don't know if everyone is aware or not, but there was a document for the installation of carbon monoxide detection and warning equipment, and that was called NFPA 720. It was out for maybe 4 cycles, came about in the early 2000 timeframe. And the document was created to help those building inspectors that were fire inspectors or fire marshals. It was thought that they could have their own document that could be utilized as they were inspecting these CO devices. But then in our industry, CO has become more mainstream to fire alarm like safety, and it was thought by NFPA Standards Council to pull 720 requirements out, put them into 72, and just disband NFPA 720. So the last edition of 720 was 2015. The Standards Council for NFPA, they have oversight of all 300 and some documents that NFPA has. They're kind of like the Supreme Court for the U.S. They watch to see what the other committees are doing, make sure nobody ever steps their bounds, and then they give them approval, though, to if they want to change their scope or anything like that. So in 2010, 72 committees requested to the Standards Council to have their scopes changed, to allow it to be broadened to not just handle fire alarm, but also do mass notification, area of refuge, a lot of other things that have now been connected or tied in with the fire alarm systems. So that happened, and the title was changed, although not drastically. National Fire Alarm and Signaling was added to the code in 2010. So a lot of work took place to make this happen. And you might think about it, it's like, well, it's just carbon monoxide detectors. Go into Chapter 17, add a section, and move on. Well, it's a little bit more to it than that. How do I use notification appliances? How do I do test and inspect in Chapter 14? What do I do about documentation in Chapter 7? What about fundamentals, how they're supervised, how their secondary power is done in Chapter 10? And so it just permeated the document to bring all of these requirements in. So it was a big undertaking to make that happen. In NFPA 72, documentation chapters, Chapter 7, and one of the things in our lives today, whether it's with 72 or NFPA 13 for sprinklers or 101 or whatever it is, it's documentation. Document what you did, and in some cases, document what you didn't do. And it's been such an issue for us in the life safety realm that 72 decided it was time to add a separate chapter devoted to documentation. A lot of our forms are there. Any kind of requirements for what needs to go into the systems is found in here as far as lining up with the IBC, what the submittals might have to have, cut sheets, all of that is in here. So then it was questions about, well, what does Chapter 7 cover? Since 72 does so much, so it used to say you needed to use this documentation chapter for new fire alarm supervising stations, shared equipment, emergency communications, and whatnot. And there were some systems that people would come to 72 and say, well, it doesn't cover, it didn't say for my particular thing, so I don't have to use the documentation chapter. And 72 just said, let's just forget it. If it's in 72, you've got to use Chapter 7 for documentation. So new systems, additions or alterations to existing systems. So whether it's area of refuge, gas detection, mass notification, whatever it is, you're now under the requirements of Chapter 7 as well. And also, as all of our codes and standards are that we use in the United States, they're minimum requirements. You can do more, but you can't do less. One of the things that I see repeatedly not being adhered to is this documentation cabinet. 72 in 2010 added a requirement for all record documentation needs to be stored in a separate documentation cabinet, or if it's stored in another location, some kind of a placard to tell me where that is. Basement, filing cabinet, the engineer's office, or what have you. The point is you can't have paperwork inside the control units any longer. I remember back when I was a technician, you'd go to a job site and you'd push the door in a little bit, turn the key, and then the door would pop out and all the drawings and documents and submittals would fall on the floor. Can't do that. So since 2010, it's been in the code, but people aren't doing it. So much so that NFPA's liaison came to the committee and said, look, I keep getting questions and I see problems with this, and people still putting documentation in the control units. Can you help us with that? So typically codes and standards are written in positive language, not negative language. Usually they tell you what you have to do or should do, but not what you don't have to do or what you shouldn't be doing. So here's a case that's kind of unique when you see the no record documentation shall be stored in the control unit. This also is something that we call in the code world giving the teeth to the AHJ. So when a fire marshal comes in and says, hey, you can't store paperwork in the control unit, where does it say I can't do that? 7723 specifically states no record documentation shall be stored. So you get the idea. And then the other question was, does documentation, as far as NFPA is concerned, does it mean physical paper? And NFPA has said over and over again throughout many different documents, documentation does not mean paper. Documentation means just that. How you provide it's up to you. PDF, electronic, paperwork, stone tablet, whatever, that's fine. So in the annex, the intent is that paper or electronic documents are not to be stored in the control unit. So here, down at the bottom, this is an example of what they're looking for. People will ask me, well, Roger, how big does this storage cabinet need to be? That's up to you. There's no requirement in code for size. It just needs to be prominently labeled as fire alarm documents. So our friends at Space Age, a good partner of Johnson Controls, has developed, they're one option for you to use. They have documentation cabinets. What I like about what Space Age has done is they even have a USB interface here that you can use a thumb drive stored inside this and download your files to it. Put in CDs, you can put in your canned smoke if you want into this box. Now for Johnson Controls, the Autocall 4100, for example, we have that memory card built onto the CPU. Yes, that is an acceptable way of you to store digitally your O&M manuals, your shop drawings, your data sheets, test and inspect documents if you scan them in and make them into a PDF. That is acceptable way of doing that. So it's another option that you have to. Now, something that's new for 2019 is how high and how low can the fire alarm control unit be on the wall? And as a person who's been in the industry for a very long time, it's kind of, scratch your head and you think, why didn't they do this a long time ago? And that's kind of what the committee said when they were around the table talking about this. It's like, gee, what do you mean there's nothing in there about how high or how low? Yes, you could kind of sort of get there in the NEC, the National Electrical Code, for electrical cabinets and how they should be mounted on the wall, but it didn't specifically say fire alarms shall be mounted to this height. So now what we're talking about is it's not the cabinet itself, it's talking about the control unit display, visible indicators, LEDs, the switches, the things that you interface with, they can be no higher than 6 feet. So right here it would be this top of this display can be no higher than 6 feet. And then likewise for the bottom part, the switches, LEDs, can be no lower than 15 inches off the finished floor. So again, it's not the cabinet, it's what you interact with, you interface with, 6 feet and 15 inches. So here is another a change. Although the requirement is the same, the document has been modified a little bit. So I wanted to kind of just point out maybe a manual of style that NFPA is going towards or enacted, but also to remind you about this section, because again, this is one of those that I don't see people doing all the time. So there have been cases in the United States where a fire alarm control unit's in a basement, electrical closet, somewhere that's not continuously occupied, and a fire started. Maybe other work was being done, trash can was lax, rags, whatever, started smoldering, and actually took the fire alarm out before the fire alarm was able to create an alarm to alert the occupants and or send a signal to the supervising station to get first responders on scene. So this has happened a few times where it's happened enough that NFPA has said, we got to do something to help with this. So several cycles ago, they enacted the requirement of a smoke detector to be installed above the fire alarm control unit. Further to that, because we want to, what NFPA calls to do signal preservation. We want to make sure the signal gets out to the first responders and to the people of the building, so that the smoke detector needs to be above the control unit, the notification appliance extender panel, MAC panel, booster panel, 4009, whatever you want to call it, and your supervising station transmitting equipment, your DAC, your IP communicator, cell communicator, what have you. Now, if all of these are in the same room, this picture that I have here is compliments of Norel Fire, a fine auto call dealer in the Northeast. If they're all in the same room like this, one smoke detector is fine, as long as it's within 21 feet of the of every control unit or NAC panel. And if you have 4009s, for example, in closets throughout the building, you need a smoke detector above each one. If you have miniplex transponders out there that have power supplies to activate speakers or horns or strobes, you need a smoke detector above that. So that's the requirement in what's in here. What NFPA has done to change their manual of style is they're telling the committees where you can stop using exceptions. The code should be able to be standalone. I shouldn't have an exception that's possibly open to interpretation. So here, the code has said you need to have a smoke detector at each of these devices, or if the ambient condition prohibits it, a heat detector. Now, you can argue that, well, gee, if it's ambient condition doesn't allow a smoke detector to be there, is it really a good place for a control unit? And that's another discussion. But if we find ourselves in those situations, the code allows us. So they've got rid of the exceptions and put a smoke above your control units. And there's been a lot of debate. Well, what if I got a sprinkler head in that same room? That's fantastic. Doesn't matter. Sprinkler head helps to quench a fire or stifle a fire or perhaps put it out, but it's not made to be the early warning fire detector for a fire alarm system. There's been a lot of debate about that. And the sprinkler systems have that really nice, clean, great water that comes out of it, right? Not. It goes right into the top of the fire alarm panel. And what do we have up here that UL requires us to have? Little vents for the heat to escape. A great channel for that nice water to go right inside and take out the control unit. So whether there's a sprinkler head in there or not is irrelevant. The code requires it to be there if it's in an unoccupied area. And then along with that, again, another thing that you don't have to do, what if I have a dedicated function fire alarm control unit? Do I need a smoke detector above that? Well, let's back up and talk about what's a dedicated function system. So if I have, this was enacted a few cycles ago, or added in a few cycles ago, if I have a two-story parking garage, open air, the building code doesn't require a fire alarm system in that structure. It might have to be sprinklered, but it doesn't have to have a fire alarm. Okay, fine. But it does require, in a two-story building, an elevator. So if I have an elevator, the smoke detectors need to tie to the fire alarm control unit. I don't have a fire alarm control unit, so what do? So the code says, let's create a system, and we can designate it as a dedicated function system. And the whole purpose of that is that when you write up your plans, you write down that it's not a fire alarm, it's a dedicated function fire alarm. And it tells people that it's there for one specific purpose. In our price book, we have an applique that you can change on the front of this control unit to say dedicated function. It's the same exact cabinet, electronics, programming, listing, everything else that goes with it. It's just we call it something different. Remember, it's documentation. So we put it in a new system. Everybody understands that. But what if I didn't change it? Well, 2 years from now, I got a different inspector from the city coming in. I have a different contractor coming in to do the inspection. I have a different building owner, and nobody knows or is aware of all of that. So a good inspector will come in and say, hey, I'm here to inspect your fire alarm. Oh, hey, where's your smoke detector above the control unit? Well, it's a dedicated function. Where's your one pull station that's required? Well, it's a dedicated. Where is the horns, your strobes, and all the rest of that? Well, that's not what it is. It's just a dedicated function system. How do they know that? So you have to call it a dedicated function control unit. And because it doesn't have a signal that needs to be sent to the occupants or off-site, you don't need to put a smoke detector or a heat detector above that control unit. So hopefully all that makes sense to you. Another one that I see has been modified a little bit over the years, but I see people, again, not adhering to the code. The disconnecting means, the circuit breaker, the power that goes to our control units, whether it's a 4009, a DAC, or whatever it is, we need to make sure that it's marked for fire alarm or mass notification use. This is what the code's looking for, something like that. Again, our partners at Space Age have these generic plates that can go over top of pretty much all the circuit breakers that are used in the U.S. I think they should be in your price book if you look under Space Age. But it's not that we're trying to sell these or we're trying to corner the market on fire alarm circuit breaker stop devices or disconnect devices. But what we want is something that's easy for you to find and be able to use and adhere to the requirements. And the reason that this has come about is two main things have been happening. One of them is certain areas of the United States will use these circuit breakers as light switches, and they will go in every morning and every evening to turn on and off the lights in various areas. Now, I know the electrical code says you're not supposed to do that, but some of these government entities, and I can give you several examples of where they are in the U.S., do this routinely. The unions require the person to be able to turn the lights on and off, only the person that the union authorizes, so the cabinets are locked up, and sometimes they turned off the wrong breaker, and then the fire alarm was without power, the batteries died, and then we didn't have a fire alarm system. Sometimes it also occurs where maybe I'm a business person and I work in an office building and we plug too many things in the conference room and we trip the breaker. So I say, well, gee, I'm not an electrician, but I've seen the person do it all the time, open up the cabinet and just start turning breakers on and off till I find it. And inadvertently, they turn off and leave off the wrong one, and the fire alarm goes without power and it dies. So that's why the deterrent is there. It says a circuit breaker lock, not a padlock, not a key lock, just some kind of a deterrent so that if you're going up and down, you don't accidentally turn the wrong one off and leave it off. So again, it needs to indicate just like you see there. So let's talk about carbon monoxide a little bit before we jump into Chapter 7. We've been talking about CO and being added into the code, but what is CO? How does it affect the body? And we have to go back a few years for this one. OSHA got involved. Some industrial facilities where carbon monoxide is something that is just in their environment, they have to live with it, whether you're in a warehouse, maybe that has a propane forklift, and you have carbon monoxide being emitted from that, or what have you. So OSHA was asked, how many parts per million of carbon monoxide could be in an environment that I'm working in, and I'd be able to work in there without it affecting my body? So that's where the 8 hours comes from. So the OSHA came back and said, you can work for 8 hours, typical day shift, in an area that has 50 parts per million or less, and it won't affect your body. Then they also said if you have 800 parts per million, you start to get headache or dizziness in 45 minutes and collapse unconscious in 2 hours. 1,000 parts per million, loss of consciousness after an hour. 6,400 parts per million, headache, dizziness 1 to 2 minutes, 10 to 15 minutes, possible death. So with carbon monoxide, it's concentration levels and it's time. Our blood cells want to eat up oxygen, but our blood cells will look at carbon monoxide molecules like candy, and they want to eat the candy first. So the red blood cells in our body will start to eat up the carbon monoxide molecules first, fill up on that, and then there's no room left for oxygen, and our body literally suffocates for air, for oxygen. So then it takes time. It takes time for that to happen. The more there is, the shorter the time it takes. So carbon monoxide detectors then don't function like a smoke detector does. I don't need a certain amount of smoke and then boom, my detector goes into alarm. Heat detector, get to a certain temperature, boom, go into alarm. CO works differently. So UL had to get involved because early on, CO devices actually did operate that way where they saw a little bit of CO and they went into alarm. And we had false alarm issues, carbon monoxide. Companies were kind of under the gun saying, look, you've got a massive amount of nuisance alarm issues. Consumer Product Safety Commission got involved. So UL came out and said, okay, let's develop a criteria for carbon monoxide devices to function. And I have both listed here, UL 2034 and 2075, whether you're a single station carbon monoxide device, standalone, or you're a system device, the functional requirements of how they operate are identical. So I go as Johnson Controls with my product to Underwriters Laboratory, and I say, okay, I want this device listed to UL 2034 for a detector. So they do that, and the first thing they do is put it in a room, seal it up, inject 30 parts per million, start a watch, and you got 30 days. That's not a typo, it's days. So I cannot go into alarm with 30 parts per million in the room until after 30 days have completed. If I go into alarm on the 28th day, I failed the test. So if I pass that, now I take and clean the device out, clean the room out, put the device back in the room, inject 70 parts per million, and now the timing changes. I have to go into alarm no sooner than an hour, but no later than 4 hours. Pass that, clean out the room, do it again, inject 150 parts per million. Cannot go into alarm before 10 minutes, but not after 50. Clean out the room, do it again, 400 parts per million, not before 4 minutes, not after 15. So this is why carbon monoxide devices are a little bit more expensive when you go to like a big box store to buy one, off the shelf, Home Depot or Lowe's. And they're a little bit more software intense than a smoke detector is, because I need to write algorithms to make this happen. Because what if it's 223 parts per million? So the system needs to be able to take and extrapolate the timings and the parts per million and come up with a time when it needs to go into alarm. What if it's 80 parts per million for 5 minutes and 100 parts per million for 30 minutes? You get the idea. We need to be able to do all of that. So there's a lot of smart stuff that goes into these devices. Now, carbon monoxide detectors, where do we put them? Well, carbon monoxide is odorless, colorless, and tasteless. You don't know that it's in the environment. Research has been done to prove out that CO has the same specific gravity almost as air. It mixes freely and mixes quickly in our atmosphere. It doesn't float, it doesn't sink, it goes everywhere. In some cases, and it's maybe another presentation for another day, there's actually been studies to show how it propagates through walls. Yes, walls very quickly, within minutes, not days or hours, minutes. So with all that being said, we need to talk about spacing of carbon monoxide devices. Since it moves so quickly, it migrates so fast, there really is no need for spacing requirements. There is no spacing research that's been done or has been decided by the committees of NFPA that there needs to be done either. So if anybody's telling you that carbon monoxide devices have a certain spacing criteria, that's not true. Unless that company has done their own research, that just isn't the case. Carbon monoxide devices are used when we want to detect incomplete burning of fossil fuels. So that's the case. So what's a fossil fuel? Propane, natural gas, wood, coal, oil. You have a fireplace with wood inside it? Yes, it's a fossil fuel burning appliance. And that's the key in our building codes. A lot of the building codes today, 2018, some in 2015, but in 2018, both the IBC and 101 really started to enact carbon monoxide detector requirements in a lot of occupancies. And the trigger is, does it have a fuel burning appliance, a gas stove, a gas fireplace, or wood stove, anything like that. So where do we put these things? Since we don't have spacing requirements like we do with smoke detectors or heat detectors. So the first one there is on the ceiling in the same room as the permanently installed fuel burning appliance. Well, wait a minute, you just said ceiling, but you just told me it mixes freely with air. Why do you say the ceiling? Well, the key word here is burning. The characteristics of something burning requires or makes the air that surrounds it warm. And where does warm air go? Warm air rises. The thought is, if we put it on the ceiling above the fuel burning appliance, that warm air is going to go up and take CO with it. And we'll be able to detect it as quick as we possibly can. That is the only reason it says ceiling for line number 1. Then it says you need to have one on every habitable level. So if you have a 4-story building, at minimum 1 per floor. And then in every HVAC zone of every floor of a building. So if you have 1 HVAC per floor, all you need is 4 devices, assuming it's not a hotel, motel. We'll talk about that in a minute. If you have 2 HVACs on a floor, you need 2, one in each HVAC per floor. And then in addition to that, a lot of our problems have occurred where people are sleeping. Carbon monoxide affects our body by making us feel nauseous, sick, feels like I got the flu, I want to lay down, I want to take a rest. So naturally, we want to make sure that the areas that people are supposed to be sleeping in are also protected. So what the code has added is, let's make sure that there's a CO device outside of each sleeping area, each door within 21 feet. So if it's a guest room, guest suite, college dormitory, apartment complex, hotel, we want to have these CO devices down the hallway within 21 feet of every door. So wait a minute, again, you just told me there is no spacing requirements for CO. Where did 21 feet come from? Specifically a certain number that says 21, not 20, not 15. And, for me, whenever I see a number like that come up in our codes, whatever it is, I always like to do investigation to figure out why is it, where did it come from, why is it used? Well, if you look down here in the bottom right corner, this is an example of a Johnson Controls Autocall carbon monoxide detector. The detector here is built into the base. It's a cartridge, and pretty much all of your systems people, Honeywell, Siemens, Hotiki, Bosch, we all put carbon monoxide devices in conjunction with our smoke detectors. So the committee realized that, and the committee said, we do not want people to somehow overestimate where their carbon monoxide devices will go or overestimate where the smoke detectors go, because these are going to be combination devices. So why don't we take the one that's most stringent, smoke detectors, and say you need to have a carbon monoxide that's going to be tied to a smoke within 21 feet. So if you've done any spacing calculations with smoke detectors, 0.7 of the listed spacing to the furthest corner gets you, the hypotenuse of the triangle gets you to the 21 feet. And so that's where that comes from. And then anywhere else that your local laws or codes may require, and we see in many of our codes and standards today, if you have a performance-based design that can either do the minimum that the code has in a different way, or better for what the code has to say, that is a way that you can go back to the AHJ or the engineer of record and say, look, I thought it was a better performance-based way of making this happen. I hope this kind of makes sense. If you go on, the listing requirements, 2075 for sensors, 2034 for single-station, multi-station alarms. The requirements of how the devices function are identical in both, but for carbon monoxide alarms, the requirements are in there for the sounder, how it operates, and for secondary power for the devices in there. So that's why it's a separate standard. Now, with Johnson Controls, the Autocall line, we have our cartridge in the base, and then you can have a smoke detector, and in some cases even a sounder base in conjunction with a CO device. And you could use this in an apartment or in a room, and if the carbon monoxide device sees an alarm, it can activate the sounder base of that device. So some codes will require that the carbon monoxide alarm be installed in the rooms. And you go in and say, look, I got a sensor with a base. I want to use this instead of the cheap device you buy down from Home Depot. Well, for us to be able to do that, we want the UL and gutter device listed as both. I'm listed as UL 2075 for a sensor and 2034 when combined with a sounder base as a single station alarm. The same is true, side note, for smoke detectors. When you put a smoke detector with a sounder base, it's listed as a UL 268 smoke detector, but when I have the base and have it work as a single station smoke alarm, it's also listed as UL 217. So we've done both at Johnson Controls. So wherever you're installing it, you're covered. And then the general stuff on how the device needs to be mounted, not vibration area, jarring area, what have you. And before I leave this, let me just talk about a couple of other things real quick. I have seen some duct carbon monoxide devices on the market. And I get calls on this saying, Roger, am I allowed to do this? Code does not address carbon monoxide duct detectors because there is no UL listing for it, there is no standard for it, there has been no testing for that. So if any of those that are out there that are in use, they are strictly for environmental use, meaning I see a certain part per million, I turn fans on, maybe alert the HVAC system or something of the like. But they are not suitable, listed, or to be used for fire alarm life safety use. And the other thing is our carbon monoxide devices, all manufacturers' carbon monoxide devices need to have a date stamp on them. It needs to be encoded in the device, and the device needs to indicate an end-of-life signal. So for carbon monoxide, it's going to depend upon the manufacturer as how many years you get out of their device. Some are 5 years, some are 7 years, some are 10 years. With Johnson Controls Autocall devices, you're getting 10 years out of your carbon monoxide devices. And it's from the date of when the device was manufactured. I can't tell you how many times I've gone to installations or talked with people, and I said, why do you still have the orange covers on the carbon monoxide device? Well, the building's not being taken over for a few more months, and we want to make sure that the timer doesn't start, and we don't want to expose the device to the atmosphere and change that time. We want to get the full 10 years out of it. Sorry, as soon as I manufactured it and it left the line, the clock started ticking. So you need to look on the back. And our devices will send a signal to the fire alarm control unit and indicate when they're getting close to end of life as far as a year out, and they need to be replaced. And for those that don't know, these devices, these cartridges, are very easy to do, and the end user can do it. There's no tools, no programming that needs to be done, no switches that need to be set. You can just pop it out, pop a new one in, the system recognizes it, and away you go. Let's jump over to air sampling devices. Air sampling devices, basically it's some kind of a smoke detector in a box, if I can just make it simplified. It has a fan that's pulling the air into it, sampling the environment, and it has these sampling holes or ports scattered throughout the room. Some people have taken air sampling systems and said, look, you don't need to put 20 smoke detectors in this room. I can do it with one air sampling system, and all I need is one port, and the port just pulls the air from the room, and I can detect smoke in the area. Well, that's not true. Each port needs to be tested or designed like it's a smoke detector and spaced appropriately. And there is software to make that happen. If you use, for example, Vesda. Vesda is a big partner with Johnson Controls. There is Vesda's software that you use to design the system. How big is my area? How high is the floor? And it will tell you the size of the tubing, how far apart the holes go, the size of the holes, the end cap that you use, the speed of the fan. Everything is calculated out. So what this section is telling you is if you don't have that performance-based design criteria, every port needs to be treated like a spot-type detector and spaced like a spot-type detector. Additionally, if you are going to use software, it's got to be something that's listed for use with the manufacturer's equipment. There has been several cases where people are using Excel spreadsheets, rule of thumb, drawing it out, and just kind of guessing where these sampling ports should go, the size of the holes. So the code had to be changed, and in 2019, 1773624 was added, which blue is new. Software applications for the design of these networks shall be listed for the use with the manufacturer's equipment. So again, trying to give the teeth to the engineers, the AHJs, that when you get a submittal that has a layout for an air aspiration system, you can challenge and say, great, how did you do this? What software did you utilize? And then along with that, the sampling pipes need to be labeled, that the ports are used for inspecting the fire alarm, or for the sampling ports for the Vesda systems or air aspirating systems. In some cases, you walk into some buildings and you see the holes, and they're every 30 feet or so, and you kind of know what they are because you're in the business, but an average person wouldn't know that. And then also the ports need to be identified, and the piping needs to be listed. There are still many, many cases where people buy the equipment and then go out and run down to the supply house and buy regular old PVC piping or conduit and use that as their piping for their air aspiration system. Can't do that. It's got to be listed for that usage. So now we switch back to the notification side and carbon monoxide detection. When the signaling for evacuation was standardized in the code back in the early 1990s, Temporal 3 was added into the code as the mandatory evacuation signal. Beep, 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 beep. You've all heard it over the years. And that's actually used worldwide. It wasn't something that NFPA created. The Acoustical Society of America created it and stored the standard long time ago, and NFPA latched onto that when they realized back in the early 90s that that was what people were using globally for an evacuation tone. Now it's changed a little bit, not the code itself, but the 72 has changed a little bit of how temporal 3 is to be utilized in our code. It used to say temporal 3 was used for evacuation, when you heard beep, 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 and then evacuate the building. That no longer is the case. Code now says temporal 3 is to be used to indicate not to be where you are. Meaning if I hear temporal 3, I need to relocate, go to another floor, or possibly evacuate, depending upon the response plan for that building. But it doesn't mean anymore that I have to evacuate. So now we have temporal 4 come along for carbon monoxide. The Carbon Monoxide Committee in NFPA 720 back in the early 2000s said, we need a different signal. We can't tell people temporal 3, because at the time it meant evacuate, but it really should be up to them on what they do when they hear or know that a carbon monoxide device has been activated. This is where temporal 4 came into the code. They said, let's give them a different signal, something to alert people, to let them know a different type of event is going on. And you might say, well, why do I want to know that? Well, in some buildings, it depends on your emergency response plan. The strategy is if you hear the new temporal 4 go off, your first reaction may not be to go and evacuate or relocate. Your first reaction might be open up doors, open up windows. It causes people to fall asleep. Check on your colleagues in other offices or dormitories, other rooms, make sure people are awakened to get out. So NFPA tries to give you the tools for you to do what's best for your facility. Just like strobes for mass notification don't have to be amber. It's up to you to figure out the best color. You see this in code over and over again. So it's a modified temporal 4, if you will, and it's a staccato. Beep, 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 and then a long pause. Beep, 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 beep. So the idea is when you hear that different tone, a different cadence, that you are going to then be aware that it's carbon monoxide device has been activated, and then take the appropriate action. So the signals now need to be synchronized within a notification zone of a building. So we've always synchronized, or for many, many years, synchronized strobes. My strobes need to be synchronized because we have whole issues with causing seizures or other anomalies within people. But now we're worried about the audible side. This is talking about audible in 18433. So now, whether it's horns, tones from piezo's, speakers, voice messages, whatever it is that you're using as the audible indication, it now needs to be synchronized in a notification zone. So if you have a floor, a big floor, maybe it's being covered by maybe 3 notification appliance circuits, I need to make sure that all 3 of those circuits, all of the horns, strobes, speakers, whatever they are, they're synchronized. Meaning I'm hearing the tones, beep, 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 I'm hearing the voice, the directions, they're all synchronized. Now, with Johnson Controls Autocall, that's not a big deal, right? If I have a fire alarm control unit and I use IDNet to 4009s, everything's synchronized whether you want it or not, in the whole building, whether you want it or not. The problem might occur, though, where you take a notification appliance extender panel, tie it into an older hardwired fire alarm, and you're trying to maybe synchronize devices together. You might need to have synchronization modules or some other way of making sure that your NACs are harmonized or synchronized together. So just be aware that going forward here in 2019, they all need to be synchronized for audible in a notification zone. Not the whole building, just the zone, the notification zone. Notification zones are made up from signaling zones, signaling circuits. You can have 3 signal circuits then that create a notification circuit or zone. And for carbon monoxide alarms, the requirements in Chapter 29 do not require synchronization. Chapter 29 is a whole separate animal, and they kind of do what they want over there. So let's change to strobes for a minute. When LEDs came on scene, there have been issues where not all LEDs are created equal. Some LEDs are more intense than others. Some ramp up, hit their peak intensity, and ramp down rather quickly. Others take a little bit longer of time. what was being found through research at NFPA was some LEDs that were taking a long time, relatively long time, 100 milliseconds, to ramp up and ramp down, weren't hitting their peak intensity quick enough to alert you. Now, excuse me, if you're looking at a device walking down a hallway, not so much a big deal. I can see the strobe right in front of me. But if you got your head down, you're working at your desk, and the strobe's behind you, you're looking for indirect viewing of the strobe being reflected off the floor, the ceiling, the walls to alert you. A slow ramp up and a slow ramp down may not alert you to that. And there's a lot of studies out there from NFPA to prove that out. So in 2016 edition of the code, they laid the law down and said you need to have 20 millisecond pulse width for your strobes unless you're using them for 18.5.5.5, which is for hallways. In 2019, they dumped the exception and said 20 milliseconds no matter where you are. Now, the issue is there are some manufacturers on the market today in the United States that are listed that have a greater than 20 millisecond pulse width. Some of them are manufacturers that you know very well, not Johnson Controls. So they petitioned NFPA and said, look, we developed these devices way before you changed the standard. I spent a lot of money getting them listed, engineered, out to market. What do I do? So NFPA said, how about we give you a derating ability? So you may have heard about LED strobes needing to be derated. Well, that's true, depending upon your manufacturer. So it all starts with the 20 millisecond or less. If you have an LED that fires, hits peak intensity, and discharges below 20 milliseconds, you're fine. Do a 1-for-1. Johnson Controls Autocall LEDs, we're around the 9 millisecond pulse width. Plenty of room in there. We actually lobbied as a company to make it 10 milliseconds, not 20. So you don't have to worry about this whole derating thing when you use Johnson Controls Autocall LEDs. Doesn't affect us at all. But if you're using some of the competitor products that are out on the market today, not all of them, but some of them are running 80 millisecond pulse width. So that means if I have a 20 by 20 area, I can cover it with a $15 appliance at per 72. But if I have a device that's running at 75 millisecond, I need to now derate that device or multiply that device by 3 times. So where I'm using a $15 the competitor that has a higher pulse width, they have to use a $45 to be deemed equivalent. So on our data sheets now, a lot of manufacturers, we are now have to put our pulse width out there. And if you're buying strobes other than Johnson Controls Autocall strobes and they're LEDs, you need to ask the question, what is the pulse width of your LED strobe? Because if it's greater than 20, I've got to do some derating. So this is where you start to see some manufacturers claiming that their LEDs are so much more efficient than other manufacturers. And when you dig into it, yeah, yours is drawing a lot less power because yours has a longer pulse width than ours do. So I hope this makes sense. If anybody needs more clarity on that or you have questions, please reach out to me on this. I am glad to help you with this. Protected premises. Protected premises chapter for years has always been fire alarm. That's all they did. Anything else was out of their realm. Well, our world's changed a lot in life safety, and so much so that they no longer say they just do fire. They do pretty much anything in the book. So they dropped the word fire from the title and the scope of the document, and now they do all alarm and signaling systems are now covered under Chapter 23. Verbiage means everything. I was part of a task group. I put in a little over 110 proposals for this cycle on the terminology of certain things. You know, is it a speaker or is it a loudspeaker? And you might sit back and say, come on, this is semantics. Well, this is wording. This is what we do for a living. We should use the right words. So a speaker is me. I'm talking. I'm speaking in this presentation. A loudspeaker is the device that goes on the ceiling or the wall, connects to the fire alarm system. You get the idea. And as an example of this, and I did this work, activation versus actuation. I'm supposed to, in my fire alarm system, to activate relays or devices to turn on fans or other emergency control functions. Well, the activation is the observance of it. The actuation is causing it to happen. Am I playing baseball or am I watching baseball? So activation was removed, actuation was added in. I know this is my world, and this is why it's boring to be me sometimes. Carbon monoxide signals. So where do carbon monoxide signals, how do they need to be enunciated? So in Chapter 23, 8.4.9, carbon monoxide devices, unless otherwise permitted by point 1 below, detectors in the carbon monoxide systems transmitted to a fire alarm shall be indicated as a carbon monoxide signal. And this, by and large, now is a requirement in our code today. You can't bring these in as supervisories, as troubles, or fire alarms. They're going to be identified as what they are, carbon monoxide. Now, there are some cases where the building owner has a different emergency response plan, and they could come in as supervisory signals, but I see that seldom. I've seen that seldom used here in what we're doing. So if you have, for example, a simplex or an Autocall system, and you have the LEDs on the side and you have the function switches on the side, you can designate one of those to light up and indicate a carbon monoxide system has been activated, a detector has been activated. That meets the requirements of the code. So although we still have priority 1 or fire alarm, we have supervisory, you have trouble, you can have the extra one on the side. I bring this up because if you're working on an older system and the customer says, hey, let's add some carbon monoxide devices to my older system, and maybe it's an old hardwired system or even an old addressable system that doesn't have that ability, you've got to figure out how you're going to make this happen. So either the customer changes their response plan and the AHJ buys off on it, or you change out the head end. Excuse me. So again, these are the tools that NFPA is trying to give to the engineer, the building owner, the installer, maintainers, so that when you are in a facility, you do what's best for you, and the system then will meet those requirements. That's why we keep talking about this emergency response plan or how the building is going to be operated. So what about occupant notification? This question comes up a lot, and there's a lot of confusion out there. So let's run through this. So in Chapter 23, Section 8.6.1.2, except as permitted below, and we'll get to that, occupant notification of carbon monoxide systems shall be throughout the protected premises. A lot of people stop there, and they say, okay, carbon monoxide, I need to do temporal 4 everywhere in the building. Well, let's continue on. Where carbon monoxide signals are transmitted to a constantly attended on-site or off-site location. On-site location could be hotel lobby. Somebody's always in that lobby at the reception desk. Off-site could be, I'm sending it to a supervising station who monitors the building's system. So that's what we're talking about, on-site, off-site. In accordance with this chapter, and selective public note occupant notification shall be permitted to be limited to the notification zone encompassing the area where the CO alarm signal was initiated. So if I'm at a constantly attended location monitoring the system and or I'm sending it off to a supervising station, I've only got to make the temporal 4 signal activate at minimum where the carbon monoxide detector activated. So this is the confusion that people start to get. Well, I got to go them everywhere. No, you only need it in one area. Now remember, this is minimum requirement. So the code says at minimum you have to do the area. So if you say, well, gee, I want to do the whole floor or floor above, floor below, that's fine. If it's monitored on-site or off-site, you can do that. If it's not monitored at all, you've got to send the signal everywhere. And then 8.6.3.3, the boundaries of carbon monoxide alarm notification zones shall be consistent, shall be coincident with the area where the alarm initiation originated and other signaling zones in accordance with the building's emergency response plan. Again, it goes back to the response plan. I hope that makes sense. I hear a lot of confusion about this part. And again, if you have any questions about this, feel free to reach out to me anytime. Getting close to the end here, Peter. I know I'm getting close on time. Building System Information Unit. Probably a lot of you haven't really heard about this, and I'm sure you haven't seen it yet because nobody has a listed product yet. We as an industry, for many, many years, all of us, right? Siemens, Honeywell, Bosch, Hitachi, Johnson Controls, We've all had graphics-based computer systems to interface with our fire alarm control units. Typically, they've been very expensive, which is why only larger customers purchase them or high-end customers purchase them. I have to buy the computer that's listed for fire alarm use and put software on it to do that. And typically, you're in the tens of thousands of dollars to do that. So there was discussions for the past few cycles at the NFPA 72 level on, is there a way we can start to use, let's say, less expensive equipment, but not lessen life safety? And that was the genesis behind this BSIU. So first thing that was created was the definition, 3.3.34. All of our definitions are in Chapter 3. It's a computer-based electronic device that's intended to display building information. Fine, we've always done that. You could use any kind of system you wanted to. If you're just monitoring, looking at it, it's nice to know. You could buy any printer you want, any CRT, any computer, and plug it in, have a nice day. But the next part, execute system control. Whoa, timeout. These systems can't reset, they can't silence, you can't do disable. You get the idea. But now we're saying they can, including fire system information display and control. This was the game changer for us. So protected premises, Chapter 23 got involved, and they said, okay, let's start to use this thing. Let's define the hardware first. So a building system information unit, BSIU, shall be listed to product safety standards, not UL 864 for fire, UL 6950 for IT equipment, or 62368 for audio, video, information, and communications equipment. The computer that we're talking about is something that's, I'm going to say, almost off the shelf. When I take a UL fire alarm 864 computer to UL has me lock in time everything about that computer. So think about that. I don't sell tens of thousands of these every year, right? So I've got to lock in the processor, the motherboard, the power supply, the RAM. I can't modify the RAM. I can't change the hard drive. I lock all that in. Consequently, I have to go back to the manufacturers that I source my components from and guarantee I'm going to buy so many of these over the next however many years and have UL verify all that. That's why these things cost so much money, plus the software I got to run and everything else. So now you come down to this UL 6950 IT. I'll just pick on that for a second. So if I just go to Best Buy and grab a computer, it's got the UL listings, but it's UL listed to make sure if I touch it, I'm not going to get shocked and die. That's about it. Maybe a little bit of noise, so I'm not interfering with other things in the area, but that's kind of all. IT-based 6950 standard, it's gone through a little bit more robustness testing from UL. Now, the difference is I can go to Amazon and buy a UL 6950 computer. You can find them on there for $800, pretty cheap. It's a different level of a computer. So we got the hardware taken care of. It's relatively, it's priced moderately now. I can start to use that. The last part here, 422, where a BSIU provides control of the fire alarm system. Oh, there's some caveats you have to adhere to. A fire alarm control unit controlling the fire alarm system shall be located within the same room as the BSIU. What's always been the pushback of using off-the-shelf computers? Well, if that computer dies, locks up, doesn't work any longer, what do I do? So what they're saying is you need to be able to get up out of your chair if the computer dies, walk across the room, go to the fire alarm control unit on the wall, and whatever you were doing at that BSIU, I've got to be able to do with that fire alarm system. So it just can't be an enunciator there because I can't do disabling, enabling of points, controlling things. But if all I'm limiting my software to on my BSIU is just silence and reset and that's it, well, then an enunciator could suffice because it's mimicking what I was able to do with the BSIU. So that, and then the software, you're able to turn a lot of these features on and off as they're installed. And the BSIU shall not be permitted to perform fire alarm control features that cannot be done by the FACU in the room. So that's a key point. Now, what's happened is UL comes into play. Up until I think it was the end of March when UL changed the standard and balloted it out. I don't know if the ballot has been finalized yet. I have to check on that. But we're just starting to catch up to this in the UL world. UL has always said if you're going to have a graphics interface component, you need to have the computer and the software listed together. There was no allowance in UL 864 up until today that would allow me to have software only that can be UL listed. So that had to change. This is why you haven't probably seen this too much out there in the world yet, because nobody can get the product listed because it doesn't exist. But I see this as a huge win for medium-sized to even smaller-sized customers. You know, this has always been reserved for the bigger government facilities, huge college campuses, big industrial facilities, because you're looking at tens of thousands of dollars to make this happen. Now, for a $1,000 computer and whatever the software is going to cost, it's very economical for a smaller hotel, a smaller private college or a school to be able to implement this graphics package and meet the requirements of the code and have everything listed. I think this is a huge win for the industry, for everybody. You know, so start thinking about some of the customers that you have out there and how this might be able to be interfaced and used as we go forward. So I know that's a lot of stuff I threw out there in this hour of time we had together. Peter, I'll be happy to answer any questions that you might have. You see my email address there. You know, if I can help, I support the Autocall line, just like all the rest of the lines that we have at Johnson Controls around the globe. So feel free, reach out to me if you have questions, concerns, if I can help in any way. I'm happy to do that.
Great. Thanks so much, Roger. You know, again, referencing back, use the raise your hand icon if you want to ask something verbally. We're monitoring the console there, and we can see when you do that. And also, you can use the chat or the Q&A windows to ask your questions. We did get a few questions sent in, Roger, while you were talking. So the first one from Bryce has to do with switches. As the positioning of the panel now, he says, if I have switches in the bottom bay of a 3-bay 4100, will the switches be 15 inches off the floor and the display under 6 feet?
Yes, if you measure because we were involved in the readiness, this is a good question, because originally when it was put out, you couldn't do that. So the question is, if I take the top of the first bay, bay 1, and I look to the bottom of bay 3, will that fall within 15 inches off the floor and within 6 feet off of the ceiling, or off the floor? I'll get it right. Yes, you can do that. Our 4100 will meet those requirements.
All right, and his other question, and I'm not sure if a dedicated control unit is being monitored by a fire alarm system that would turn on audio visuals, should a smoke detector be installed above the dedicated unit?
Well, I would actually back up and say you couldn't do that. You couldn't have a dedicated function control unit that's connected to a fire alarm control unit. Those two shouldn't exist together. That kind of goes against the intent of the code. So the answer will be no, because you shouldn't have that scenario.
Okay. And then one final question. Bryce has the hat trick here today. Are manufacturers required to put their pulse rating for their LED strobes on their data sheets?
Okay, so let's talk about that. So when I go to UL will verify the pulse width and tell me in the listing of my device what it has met. And when I look at the data sheet, because let's talk about terminology again. Data sheets are marketing brochures that I can put anything I want on. This product will work for 100 years. You never have to replace it. It's the best in the world. I can write anything I want. What you want to ask for is the manufacturer's published instructions. Have you ever noticed when you open up a pool station, a new smoke detector, there's a pamphlet inside there, there's some kind of paperwork in there, and you're like, why are they wasting all of this paperwork in these devices? That's the manufacturer's published instructions. When I send a device to UL, they verify that the device functions per the standard. Then they ask me for my installation and service instructions. And they verify that how you say to install it, they install it that way and make sure that it works properly like that. They're going to inspect it the way you say. They're going to test it and service it the way you said. So they verify all that documentation. When that happens, they call that manufacturer's published instructions. That's what's listed. And in there, you will see what the pulse rate was. So are they required to put it on the data sheet? No. Should they put it on the data sheet? Yes, they should, but it's not a requirement. I hope that makes sense.
Yeah, no, it does make sense. Thank you. There are no other written questions in yet. I don't see anyone's hand raised yet. So I just wanted to, before we tie up here, I asked you this in the earlier session too, but maybe you might want to take a few seconds for any closing remarks and also maybe to talk about the focus for the next edition, which is the 2022 edition.
Sure. For 2022 edition, actually doing a lot of work on that now. It needs to be finalized here in the next couple of 2 or 3 months so that it can be formally put together and then ready to go out for any NITMAMs by March of next year. Notice of intent to make a motion for the annual meeting next June, and then in September it would be published, hopefully, as the 2022 edition. So we're kind of coming to the end of it. One of the biggest things that I see, Peter, is cybersecurity. Whenever a fire alarm control unit connects to the outside world, there's a huge concern about bad people using that as a gateway to gain access to a customer's network. So UL has created several cybersecurity documents. Right now, there's discussion of making a new chapter, Chapter 11, for cybersecurity. So definitely in some shape or form, cybersecurity is going to be in the document, whether it's the annex or the chapter remains to be seen. But there's also been discussion about us as installer maintainers, the person doing the work, to have some type of accreditation, validation that they are able to verify the cybersecurity system that's being installed. And we're not exactly sure how that's going to unfold or what they're looking at to make happen, whether it's an app that I make sure is up to date or what have you. So we're working with NFPA on that. So that's a definitely stay tuned for more information on that one.
Okay, great. So I think we have one other question came in. I think we'll make this the last one since it's right after, and then we'll wrap up here. This is from Ryan. What is the requirement for annual smoke testing on air sampling detectors? Is it at the hole, or I assume that means the first hole, the last hole, or the test point on the pipe?
So for air aspiration systems, we need to make sure that smoke can penetrate each port, so they need to be clean. But we also, typically though, for functionality, usually the end cap or the test port at the end of the line is used to verify transport time when you inject smoke or spray smoke into that end cap. So we need to verify that all the ports are clean, and the only requirement is at the end cap for the smoke test, for sensitivity test. And there's transport times. How long did it take from the time I sprayed smoke to the system saw it and all of that. But again, it goes back to the software from the manufacturer on how that's designed.
All right. So with that, I think we'll wrap up. Thank you so much, Roger, for your time today and for going through the material. And thank you, everyone, for joining us. We'll post the replay probably in a couple of days up on the Autocall website. If anything comes to mind or you have any questions or anything, feel free to get in touch with Roger, as you mentioned, or me at peter.ryan@jci.com. We'll be happy to take any suggestions, comments, and also ideas for other topics you'd like to see in other webcast sessions that we're holding. So thank you very much. Thanks for being part of the Autocall family, and I hope you have a great rest of your day. Thank you.